Welcome to lecture 5, which is on components of a drone system and their function. In this lecture, we are going to learn what are the various components of a drone system, what are their functions, and how these are used when we are doing drone surveying. There are several key features which can significantly enhance the capabilities of the drone. And these could be the desired resolution and what are the features like live streaming or gimbal stabilization. Brushless motors, which are very common nowadays in modern drones, that gives us very superior kind of efficiency, quieter operations and longer lifespans. We should also have a very compact and, if possible, folding design of the drone system so that its carrying from one place to another and its storage is very easy. Then there are software associated with that, sensor associated with it. So many of the advanced drones incorporate those sensors which helps us in detect and avoidance of the obstacles during the flight. So they reduce the risk of collision with the other flying objects such as big birds. Now it is important that we actually select a right kind of a drone, and once we know the components and what are the features required, then probably we can select a right drone. So we should have, for example, a built-in GPS system which integrates with the drone's flight controller, and it offers features such as return to home, geofencing and stable flight during the data collection. GPS tracking can monitor the UAV function in real time and help us in locating the drone in case the signal is lost. Return to home, which is a very essential feature in the drone system, which will automatically instruct the drone to return to its takeoff position in case of signal loss or if there is a low battery during the data collection with the help of the GPS systems. Drone should also have geofencing capability, which we will learn little later also what is geofencing. From entering into the restricted area, so there are certain zones where drone should not fly. There is a feature which is called follow me feature, and drone allows it to autonomously follow you, capturing the aerial images as you move to the different location. So once we know what are the important features, what are the salient features, essential features, then we can make a right selection of the drone system. There are remotely operated drones which are actively controlled by a pilot, while autonomous drones, they will perform the function without any human involvement. So there are various degrees of automations which are available nowadays in most modern drones. So it can be remotely operated or it can maintain its position automatically in the absence of the commands from the pilot who is flying this aircraft. The relative autonomy of a specific platform will also depend on what kind of a software is used by the drone. There are various components of a drone systems. So, we will discuss them one by one. It includes camera system, sensor system, communication equipment which are there, other payloads, battery, flight controller, motor propeller, GPS and radio system. This figure in fact shows the locations where these are fitted, like GPS is on the top, then there is a flight controller system, then there is a battery which is a LiPo battery here, then we have propellers. So all these are components make a complete drone system ready for data collection. So we'll discuss them one by one. The flight controller, drone has a flight controller which operates from the ground station. You control it from the ground station. Flight controller to navigate and to land the drone. The controller all the time communicates with the drone system. So, there is a communication with the help of the radio waves. Some drones can fly in automatic mode as I told earlier, but they use a combination of some obstacle avoidance sensor and GPS. So, they take the data from the two and then they can avoid the obstacles. Then we have a transmitter, very important component of the drone system. It generates in radio frequency and alternating current, and the antenna emits the radio waves, and there are number of channels in a transmitter which will determine the number of controls it has. For example, we may have a 4-channel radio system which will be able to control 4 different things. Now, as you know that we have a fixed wing and a quadcopter type drones. So, in a quadcopter minimum of 4 channels is required, not because there are 4 motors in it, but because there are 4 controls which are required to fly the quadcopter over the area. And some of these controls are listed over here. It could be a throttle. Now, how fast the motor is spinning, that is a throttle. Then there is a pitch which is tilting the multicopter forward and backward. Then there is a roll function which is tilting the multicopter to either side of left or right, and then there is a yaw rotating the multicopter on its axis. So, that is why in a quadcopter we require 4 channels. Then we have a receiver. So, transmitter and receiver, they are combined together. The receiver is also the electronic device used to receive radio waves and convert this information into a usable form. There are 4 broad types of receivers like pulse width modulation receivers, then we have the pulse position modulation receivers, then we have the serial bus receivers, and then we have the radio receivers. So, depending upon the utility, depending upon its use, we employ that receiver in that. So, that is how a controller and the receiver will look like. You can see in this diagram the various electronic and communication components are shown. Then there are other components like antenna. Antenna is used to send and receive the radio signal for communication purpose. So, this is very important. Then there are connecting leads, connector and leads. You have to connect the various components then. Now, next is the battery, which is a very important part of a drone system because we need high output. So, today nowadays we are using LiPo battery, which serves as the power source for all the drones electronic system. But there is a lot more to be research to be done in this particular area, how to prolong the life of the battery once this is charged. Then we have a power distribution system which will distribute power from the battery to all the electronic components in the drone system and ensure the stable voltage, no fluctuation in the voltage. Then there are motors, and motor will act as a power system of a multicopter. For example, it is the fundamental part, it will help keep the drone up and running all the time. Motor is required one per propeller because there are more than one propellers in a multicopter system. So, there are drones that will use the fueled motor, but the brushless DC electric motor is the most common used in modern multicopters. These motors, DC motor, electric motors have very high power density in terms of their size, lightweight, and can spin very fast with precisely controlled speed. Moreover, they will produce very less noise and they are economical to manufacture. That is why the brushless DC electric motor is very common. These motors, there is a wide variety of physical configuration. You can see a typical example is shown in the diagram here. Now, it will depends upon the stator windings which are done here. Windings can be configured as a single pass or two phase, single phase, or two-phase or three-phase motor. The most used brushless motors are normally three-phase winding. The reliability, the easy control and efficient power transmission of brushless motors have contributed greatly to many of the drone developments in both fixed wing and rotary wing. So, this motor is playing very important role in the drone system. Then there are arms. Arm of the drones are the component that are supporting these motors, and they are attached to the frame of the drone system, or what we call the base structure of the drone system. Longer arms offer greater stability, while shorter arms allow for the better maneuverability, can move fast. In some cases, the arms are the part of the drone base or structure or frame, and they are not counted as the separate part of the drone system. Then propellers. Propellers are very important components. The propeller provide the stability of the drone during the flight, and it is composed of several blades that will rotate around an axis to produce thrust by pushing the air when the drone is moving. And the performance of the propeller will be determined by its geometry, by its shape and its geometry and its size, as different propeller geometries are optimized nowadays, so that the thrust which is produced is the maximum thrust at a given rotational speed. These propellers are frequently damaged while we are flying the drone, while we are working, and needs replacement. There are 5 main variables that are used to be considered when we are choosing a multi-rotor propeller. For example, the size of the propeller, the pitch, the blade, its configuration, its material durability and the design efficiency. All of them are important, and there is a lot of research going on in this direction, how to design the optimum propeller. Drone with the small propeller, they will use very high RPM motor, and the blades spin rapidly so that the drone fly immediately. In the diagram you can see the propeller. We have a single blade propeller, then we have 3 blade propeller, triple, 4 blades, then 5 blades and the 6 blades propeller. Now single blade propeller would be the most efficient, although they are not used because of the dynamic imbalance. So they cannot make a balance for a longer time. Tricopters, as you can see here, they are having 3 propellers, quadcopters 4, and hexacopter, for example, the 6 propeller unit and so on, they provide more stability to the drone system when it is flying. There are basically 2 types of propellers which are used. Plastic propellers, as you can see from the name itself, which are lightweight and inexpensive, economical, but they also have balancing issues because of the lightweight and produce more sound and vibration when there is a air thrust coming to that. Then the second category is the carbon fiber propellers. They are also lighter in weight, but they are very strong. They are more balanced and they produce very less vibration and the sound when they are moving with a high speed. But they are expensive and provide lower thrust than the plastic ones. And carbon fiber propellers are more rigid, more durable, life is long. During the small crashes, however, as they are more rigid, the motor bearing support higher impact during the crash. So that is what has happened. So these are the 2 types and they have their own pros and cons. Propellers in quadcopter, for example, we have 4. So out of 4 propellers, 2 will move in the clockwise direction and the remaining 2 will move anti-clockwise direction to give a lift to that. As you can see in this picture also, there are top and bottom here, they are moving in the clockwise direction, the other remaining two are moving in the anti-clockwise direction, and the speed will bring them up and down. The two blade propellers will give more thrust than 3 or 4 blade propellers, which are more affected by the turbulence, but they are more affected by the turbulence. Ideally, the most efficient flight consists of the largest propeller diameter turning at the lowest velocity. So, speed is thus a trade-off for the efficiency. So, whether we want higher speed or bigger propellers. Then next component, which is the heart of the drone system, electronic speed controller, is a crucial component element of the motor. It provides electronically generated 3-phase power to the motor and control the rotation frequency of the motor. So, this ESC is shown in this particular diagram, electronic component. ESC may have a complete programming facility, so one can do the programming including the battery mode and the throttle range. This ESC will help the flight controller to control each of the motor separately, because there are in quadcopter there are 4 motors. So, you have to control them separately to produce the correct spin speed and direction, so that the entire drone stay stabilized. So, this ESC is helping us to move the drone. The ESC are typically rated according to the maximum current they can get. The rotation frequency is controlled using pulse width modulation, which is called PWM. PWM signal from the receiver is converted to an appropriate level of electrical power that drives the brushless motor, and the battery elimination circuit, which is known as BEC, is a voltage regulator there that will convert the voltage from LiPo battery to a lower voltage to connect the supply. Then also we have universal BEC, which is called UBEC, is used under the situation when ESC does not have built-in BEC. So, they generally are more reliable, more efficient, and they are able to provide more current than the BEC. Then payloads. Drones are equipped with camera systems and the sensor systems to capture the images, to capture the data, point cloud data of the terrain below them. We will discuss more in the next lecture what are the different payloads and the sensors and their utility. So, drone may have, for example, RGB camera system or multispectral camera system or LiDAR sensors to collect high resolution images or 3D point cloud data. With an RGB camera, the ground will be imaged continuously by a moving drone, and each image will be tagged by its real coordinate systems with the help of the GPS. Then photogrammetric techniques are used once we are taking the images to create either orthomosaics from them, or we create detailed 2D or 3D maps. If we are using LiDAR technology, then what we are doing, we are measuring the distances at any time during day and night, and these high density points, 3D points which we are collecting, they can be used to create a 3D model of the ground. So, these 3D models are used to create digital elevation model or digital terrain model or digital surface model. So, DEM, DTM or DESM can be created, and we can also produce very accurate maps or models created by using photogrammetric data or LiDAR point cloud data. So, drones commonly have additional camera in addition to what just explained you, which will send the field of view to the operator. So, there is one more camera in the front of the drone. There are several Other sensors also which are essential to the flight controller. Among the most important here are accelerometer, gyroscopes, altimeters, inertial measuring unit which is known as IMU, and GPS modules. So these are categorized into different categories like position sensors. So we use here GPS sensor and we get position, and it helps us for automated navigation and geolocation of the data. Then we have the speed sensor. It allows the speed at which the drone is moving to be determined by interpreting the air pressure which is impacting the device. Then we have barometric altimeter which will measure the atmospheric pressure and gives the altitude and maintain the altitude of the drone system. Then we have inertial measuring unit IMU. It detects change in the position and orientation as the drone moves from one place to the another place. Then there are sensors which are called obstacle sensors. They actually help prevent collisions during the flight. So these are all essential kind of sensors in a drone systems. Then we have a gimbal, and gimbal is this is the part of the drone which is essential for stabilizing the camera systems during the drone flight. So they will actually, we can fix the camera into the gimbal system, various sensors, and it can fly to the area. It's a combination that is placed between the frame and the camera system. It prevents the vibration of the motors, uh, and you get good quality image captured while moving with the drone. Then we have a landing gear systems in the drone, and as the name itself is suggesting that it will provide a very stable landing and takeoff to the drone system. So this should be very sturdy. Then there is a body frame or chassis. Now frame is the skeleton and the main element of the drone, where all the components which I have discussed just now, they are all fixed in the body frame. And the design of the frame basically is a trade-off between the strength when we are adding the additional weight, for example, the cameras or the sensors, which will require actually longer propellers and stronger motors to lift the drone. So that design is a trade-off between the weight which we are carrying and the strength which is required. The frame is very important part, and it needs to be light enough because the drone is taking off, and it should also be strong enough to provide support to the components which are mounted on it. It should not break in a minor crash. If there is a minor crash, accidentally should not break, because then it will damage all other components. Drones have their own flight dynamics, which has been explained in the previous lecture also, and therefore the structural integrity needs to be met with. So in other words, the drone should be, the body frame or chassis should be strong enough to support the various component and still fly up to collect the data. The frame should be simple, they should be lightweighted and aerodynamically efficient. That is important. And stable platform with limited space for avionics. And its shape must provide a very smooth geometry having least aerodynamics resistance, so that the drone can fly without much of the resistance. It serves as the main support for the other elements like motor and electronic subsystem, the batteries, the payload, and various other devices which are the various components of the drone system, in such a way that it maintain the stability during the flight and try to keep the drone leveled. There are two types of frames which are commonly used: fixed wing and the rotary wing. So fixed wing and rotary wing, two types of the frame systems are used, and the most common types is the rotary wings which are used, and it will include, for example, Tricopter, Quadcopter, Hexacopter and Octacopter under the rotary wing. As you can see from their diagram also here, there are various types of frames. When we are talking of the multicopters, we have a tricopter which will have the 3 arms, usually 120-degree angle between the arms. And since the drone is not symmetric, this real motor is more complex than the other two, which I will explain you in order to maintain a stable flight. So quadcopter gives you perfect symmetry, 4 arms, and it is the most popular design. It is easier to construct and it is quite versatile. All the flight controllers work with this design, but if one of the motor fail, then this type of drone will most likely crash because there will be imbalance in the system. Hexacopter, it has got 6 arms, as you can see in this particular figure also, that we have hexacopter, we have the tricopter, quadcopter, etc. And it use a tricopter frame also and double the motors on the each frame. So it makes the shape of the Y, and this hexacopter goes out usually on the other motor and make it to the ground more safely than a quadcopter. The more the number of wings, the better is the thrust uplift, and it can carry more and more weights. So drone which can carry more weights actually have either the hexacopter or the octacopter. Octacopter, there are 8 arms, and on quadcopter, if you double the arms, this becomes the octacopter also. The octacopter has the same advantage and disadvantage as the hexacopter. Due to more number of motor, it becomes expensive model, but it can carry heavier payloads. That is the greatest advantage, and recover much better from failing a motor in a hexacopter. So that is the advantage of this. Then there are additional infrastructure which are required for the drones survey, like air traffic control. This is a service which is operated by an appropriate government authority of the country where the drone is flown to promote safe, orderly and expeditious flow of air traffic. Then we are using ground control station, and in ground control station basically it has a software system, it has a computer system. So on the ground, and it receives telemetry information from an airborne drone, and we can see on the display, and we can see the progress, we can see the status of the data collection by the drone system, and it also often include video and other sensor data which is transmitted. So it can be used to transmit in-flight commands to the drone. So ground control station is very important while we are flying the drone system. Then there are other terms which we are using when we are flying the drone, like first person view. The short form is FPV, and drone has a camera in the front which will transmits video directly, right, to the ground control station. So the operator can see what the drone can see while the drone is flying, how much area is covered by the drone. So that keeps the operator updated. The first person view, very important facility. The next one is the field of view, FOV. The field of view is the angle which is covered by the LiDAR sensor, or the angle at which the LiDAR signals are emitted at very significantly depending upon the LiDAR technology. So there could be two types of field of view, what is the horizontal field of view and the vertical field of view. As you can see in the diagram here also, this is the field of view of a LiDAR system. Then we are using the terms like detection range, and the name itself is suggesting that it refers to the farthest distance where it can detect an object. The sensor which is mounted on the drones can detect the object. Then we have very popular terminology which is called point cloud data. Whenever we are doing LiDAR survey, we are talking about this point cloud data. So, it is a collection of the individual data points in third dimension. So, when we are collecting the point data, it has a three-dimensional coordinate x, y and z coordinate, and that is called the point cloud data. And if we combine all the point cloud data in a given area, we have several millions of such points. For example, we can create very easily 3D map or 3D model of the terrain. Now, this is one of the fundamental types of geospatial data apart from vector data and raster data, which we are familiar with. The point cloud data comes into picture when we are using the LiDAR system. Then point density is also very important. It is the number of points which are measured by LiDAR in a defined area, and its spatial resolution of the point data is quantified as the average point density per square meter or in a unit area by an average ground point spacing. So, this point density is important because the resolution of the data will be determined by the point density. Then very important term is the positional accuracy. Whenever we are collecting the data, the question comes into the mind, what is the positional accuracy of this particular data. So, when we are talking of the accuracy, there are actually two components of it. One is the planimetric accuracy and it is the vertical. So, one is called the horizontal accuracy and another is called the vertical accuracy. In horizontal accuracy, we are talking about the two components which are x and y component. So, normally we get the accuracy at 95% confidence level of the position of the features. In horizontal, there is the latitude and longitude as well as the vertical heights. With respect to a given datum, we define the accuracy. So, planimetric accuracy, which is a accuracy in x, y and coordinate in surveying, it will refer to the accuracy of the horizontal distances which are measured between the features. Since it is a two-dimensional representation x and y of the location of the object on the earth surface, the planimetric accuracy ensures that the measurements show very accurate horizontal distance when we are using measurements from the drone systems data. Then there are some difference in the components. It depends on the drone type which we are using. So, there will be a difference in the configuration, in the shape and the size. For example, professional drone will include advanced sensor, high precision gimbals and higher capacity batteries. Whereas, if we are using agriculture drone for agriculture purpose, they will include specific spraying system, so that we can spray pesticides to the crops if required, and sensors for crop analysis. While recreational drone will have more basic components and lower resolution camera, because we do not need a very high resolution camera here. Racing drone will prioritize the power engines because it is used for speed and lightweight structure to achieve very high speed. So, depending upon the utility of the drone, there will be a difference in the various components of the drone systems. Now, when we are talking of the various components of the drone, they are opening many opportunities, from pilot drones to the electronics to the sensor system and the camera systems which are used. So, there are continuous development which is going on into the various components of the drone, how to make the drone more efficient and how to make the drone lightweight, which is housing most of these components and is still giving us the best performance. So, an increase in awareness and mission capabilities of the drone is driving a lot of innovation and new applications, and we are expecting in near future the drone will become more compact, more lighter, move with the high speed, and also the battery will last much longer when we are flying the drone systems. These are some of the suggested readings. Thank you very much.